All right, page 284 in your textbooks, and you did the review, numbers 36 to 42 there at the bottom of the page. Also did the 1 through 11 in the homework section on the next page. We'll look at that in just a moment. Before we do, let's review some things we've been talking about. We've been dealing with collections of information or numbers, facts. What do we call any collection of facts or information, Ben?
Probability.
No, that's not a collection of information. A probability is the likelihood that something happens, like the probability that you sneeze, or just kidding. Pollen season, the probability is high. What's just any collection of facts or information called, Bryson?
Data or data.
Data, however you want to pronounce it. And specifically numerical data, which is what we were working with yesterday, can also be referred to by what term? If the data is numeric in nature, we can refer to it, Luciana, as? Statistics. Very good. There's another definition, though, or thought behind the term statistics. It's actually a branch of mathematics, referred to as the branch of mathematics class that studies data. Statistics can also be thought of as the branch of mathematics that studies data. And in the study of data, we talked about taking a survey and collecting information from people. And we said that when a survey is conducted, the entire group that the survey is supposed to represent is referred to as what? The entire group about whom the survey intends to depict information. Corey? For instance, if we say the favorite fast food chain in America, well, some different opinions out there, though I'm hearing little whispers of Chick-fil-A. But if we were to say favorite fast food chain in America, well, now I've just stated that the whole group I'm supposedly talking about is America at large. Well, that means that all 330 million, 340 million Americans, class, that's the population of the study. Am I going to actually survey every single American? Of course not. I'm lazy. I might only survey the 10 of you and allow you 10 to decide the fate of America's favorite fast food. Just kidding. I should probably survey at least, I don't know, a few thousand people. I need to at least get several people from every major city. I should probably get some people in the country, right? I should make my group that I actually ask very random. What do we call the group that's actually asked the questions in a survey? Kirsten?
Sample.
The sample. So class, you only actually ask the sample, yet from that sample you draw a conclusion about the population as a whole. Good. As you collect information, again, if it's numeric information, you could average things. For instance, if we said, how many times do you go to Chick-fil-A in a year? And a person makes an estimation of about how many times they go to Chick-fil-A in a year. And then how many times have you gone to Burger King in a year? How many times have you gone to McDonald's in a year? How many times have you gone to Wendy's in a year? Whatever, you get the idea, right? And you get all these numbers and you say, well, on average, Americans go to Chick-fil-A this many times, your Burger King this many times, your McDonald's this many, and that allows you to compare what is actually the favorite fast food restaurant, rather than just asking what is your favorite. If we were to average numerical data, there's a term for it. It's shorter than the word average, which is kind of nice. Joel? Mean. Class, mean means average. Say that with me. Mean means average. And of course, to average something, Elaine, we do what?
Add them all together and then divide it by the number of atoms.
Very good technical term. Divide by the number of addends. Woo! All right, divide by the number of things you done added. But there we go. Divide by the number of addends. Great job. And we said if we were to take all of the numbers in a data set and we were to put them in order numerically. Yesterday we did this with Corey's grades, which these weren't real grades, we just made them up on the board. But if we were to take the numbers and put them all in order from smallest to largest, that's called doing what with the data? Griffin? And you can only do this with numerical data, but putting data in order from smallest to greatest. Jalen? Ranking the data. What's it called, Griffin?
Ranking.
What is ranking, Griffin?
Organizing the data from smallest to largest.
Very good. Putting it in order. And an advantage of ranking data is it allows you to very easily see, not that you couldn't have seen it another way, what's the biggest number, what's the smallest number. And that also gives us an idea of how spread out the data is. For instance, maybe there's some people that eat at Chick-fil-A 300 times a year. That would be almost daily, considering they're closed 52 times a year. But anyway, plus, probably Thanksgiving and Christmas. There's some other days that are probably closed. So let's say a few people eat at Chick-fil-A 300 times a year. Other people eat at Chick-fil-A never. I feel sorry for those people. But maybe there are some people, maybe there's not a Chick-fil-A anywhere near them. They're not everywhere. They need to get them everywhere, but maybe they're not everywhere. Anyway, obviously your biggest number, 300, your smallest number, 0, gives us an idea of how spread out the data is. What do we call the difference between the biggest and the smallest numbers in a data set? The difference between the biggest and smallest numbers in a data set. What's that called? Let's see. Who haven't I heard from yet? Have I heard from you, Corey? Corey, what's that called? Difference between the highest and lowest.
Median?
No? Okay, Kirsten?
Range.
The range. What is it?
Range.
What's the range?
The difference from the highest and the lowest.
There we go. So in Corey's grades case, we said, well, he made some hundreds. He also had a really rough day. He made 31, I think, was the lowest grade on the data set that we used yesterday. And that's a pretty big range, right? That's we don't want a range quite that big. But anyway, or maybe we're talking about points scored in basketball games. And maybe Michael has a game where he scores. What was your highest score game this past year?
12.
Mm.
It was,
If we're talking about junior varsity and
Yeah,
varsity,
JV, just JV.
Oh, 12, yeah, 12.
So you had 12 points in a game was your highest score. And then were there any games where you had no points?
No.
No, you always score. Like, me, I always score, Mr. Dasky. Anyway, so your lowest scoring game might have had only
Like 5 points.
5 points. What have been your worst game as far as scoring goes? Okay, so his range then, class, would be what? 7 points, right? From his worst game to his best game as far as scoring is concerned. There we go. Obviously, there's other ways you impact the game besides just scoring, obviously. If we were to take all the different numbers and put them in order, or class, rank them, and we just cross off end numbers, end numbers, end numbers, end numbers, salt and pepper till we get to the middle number. What's that middle number called, Ben?
The middle number.
Yeah, what's its term? By the way, it's also the same term if you're driving down the road and there's something in the very middle that separates cars going this way from cars going this way. What's that middle of the road called, Ben? They always have signs that say, keep off this.
Shoulder, median.
The median, there we go. The shoulder's on the outside, but the median there is in the middle, right? So if we want to remember the median is the middle of the road, it's also the middle of a set of data. Class, let's say this together. Median means middle. Class, median means middle. Mean means, but median means middle. But in order to find the middle, you have to put them in order, class, or rank them first. Let's take a look at the homework now. And on page 284, just some review stuff here. Number 36, Daisy writes a letter to Grandma. And I guess she's typing this letter because it talks about fonts for those who've been in computer apps. And I don't know how you handwrite different fonts. That seems kind of weird. So anyway, she's typing a letter to Grandma. She's got different kinds of fancy frou-frou paper. And she's got 6 different fonts she's thinking of using. And 10 different styles of envelopes with pretty things on them. How many different ways could Grandma wind up with a letter? And not that Grandma cares about any of that. Grandma just cares that she gets a letter. Ben?
How many?
Ooh, on number 36. Okay, what do we have to do with the different possibilities? 4 different possibilities of paper, 6 different possibilities of fonts, 10 different possibilities of envelopes. What do I do with those 3 numbers?
Add them.
No. Fundamental counting principle says we do what, class? Multiply them. Yeah, multiply them together to get what, Bryson?
240.
Should have 240 for our answer there. Number 37, newest model car is customizable. Customers can choose 4 different body designs, 3 different kinds of tires, or 30 different paint colors. I don't think I've ever seen, wow. Okay, anyway, how many different models could be crafted? You got this one, Ben? Did you multiply this time?
Yes.
What'd you get?
360.
So we don't know what, because you've been multiplying all the other ones. I don't know what happened on 36. But yes, 37 is correct. 360 different models. How many have those answers on 36? 37 questions. Yes, ma'am.
What did you say 36 was?
240. All right. Number 38. We got a little spinner there, and it says, what's the probability of spinning a green space? What did you get for that, Joel?
3 to 8.
3 to 8, because there are 3 green spaces out of 8. Number 39, what's the probability of spinning a green or an odd number? Well, how many greens are there, class?
3.
How many odd numbers are there? 4. And since it says or, we need to add to get what, Griffin?
7 7 to 8.
7 to 8. Did we get 3 to 8 on the green? We got 4 to 8 on the odd, so 7 to 8 our possibility. Number 40, what's the probability of spinning an even number or a white number? Well, how many white numbers are there, class? 3. How many even numbers are there?
4.
So the probability there, Bryson, is 7 to 8. Number 41, the probability of spinning a purple and then an even number. Well, what's the probability of a purple number, Corey? 2 to 8. What's the probability of an even number, Corey?
48.
4 to 8. But it said not or, it said, class, and. So what do I have to do when it says and, Corey?
Multiply.
Multiply. But I do want to do a little canceling here, right? The 2 and the 8 cancel to give me,
1 4.
for that matter, the 2 4s are going to.
Cancel to get 1.
So my answer is
1 to 8.
1 to 8 is the odds of spinning a purple and then spinning an even on the next spin. Number 42, probability of spinning an even number and then an odd number. Well, what's the probability of spinning an even number, Luciana?
4 to 8.
What's the probability of spinning an odd number?
4 to 8.
4 to 8. And it said and on consecutive spins, so that means we
Multiply.
multiply. Both of these fractions could reduce to just be
1/2.
1/2. So let's work those instead, and we get
1/4.
1 to 4. How many had 1 to 4 for number 42? What if it had said on number 42, class, the probability of spinning an even number or an odd number? The probability of spinning an even number or an odd number. What do you think that answer would have been, Elaine?
So it would have been 4 to 8 and 4 to 8. So would it still have been 1/4?
Or.
Oh. 1.
1. And think about it. All numbers are either even or odd, right? So like, okay, I'm going to spin this thing. I really, really hope I get either an even or an odd. Then I'll be happy. Yeah, I got an odd number. Or yeah, well, of course you're going to be happy because all of them are even or odd, right? You made it, you guaranteed it in your favor. I want to look at number 41. We had this term come up a couple days ago, mutually exclusive. Do you remember that term? Not something I'd emphasize. It's something we'll look at more next year, but I want to point this out. Do you notice how on number 41 it said spinning a purple and then an even number? What if it had said, class, the probability of an even or a purple? Well, class, how many evens are there? 4 to 8. How many purples are there, class? 2 to 8. But do you realize, class, that which is purple could also be even? Isn't there one purple even number? Which one? 2. Well, we would have just accidentally counted 2 twice because 2 was part of the 4 to 8, wasn't it? And it got counted as part of the purple. Well, you can't count it twice, right? So then on something like that, that's what we call a not mutually exclusive, where there's some overlap between the two things. Even and purple overlap with the number 2. We'd have to, well, or means add, we'd have to subtract anything that fits in both categories. And that's how we'd have solved something like that if they weren't mutually exclusive. You're not going to be tested on that this year, so you don't have to actually know that, but it's kind of floating it out there for you. You'll work a lot more with that next year. But for this year in 7th grade, every time we work, they have to be mutually exclusive. So for instance, I could say green or odd. Well, because green, there are no odd greens. Does that make sense? Or I could say even and or white, because there are no even white. Right? But the purple had a little of both. So that's where we would get into ones that were not mutually exclusive, which is why the book didn't ask them. But next year, you're going to have the opportunity to work problems like that. How many were perfect? 36 to 42. Perfect, 36 to 42. Any questions, 36 to 42? Any of these you have a question on? All right, let's look at the next page now. And at the top of the page, number 1, they say find the mean, find the median, and find the range. Well, anytime they ask for median, class, what do I have to do first? Rank them. So we should have ranked our data, first of all, here on number 1. And real quick, let's do this. We've got a 21, a 25, a 28, a 31, a 32, and a 37. Now, you notice I didn't cross them off as I did that. What's another way I could check if I don't want to cross them off? How many numbers are there? 6. How many numbers did I write down? 6. Make sure the numbers match up at least. Okay, that's another way if you don't want to cross them off. I think it's easier, especially if you're writing it right there in your book, which there wasn't a lot of room to be fair, but if you were to write them in your book, cross them off as you go. Well, if I salt, pepper, wait a second, I can't salt, pepper, class, I'd knock them off. What do I do when there are 2 middle values, Jalen? Add to get 59 and then Divide by 2. In other words, average the two middle numbers. And what do we get when we divide the 59 by 2? What was your median for number 1? Kirsten?
29.5.
29.5 or 29 and a half should have been our median on number 1. It also asked letter C for the range. Notice I'm doing the easy stuff first. The range. Well, how do I find the range? Let's go back to Jalen.
You subtract the highest.
Highest minus lowest. Well, 37 minus 21 gives me a range of 16. And there's my range. Now for the only part that involves real math, hard math, and that's the mean. Because class, we got to do what here? Add them all together. And when we add them all together, let's see, I get to 24, I get to 8, 174 when you add them all together?
Yes.
And then we got to divide that by 6. 29 for the mean.
Yeah.
And how many had those 3 answers all correct for number 1? Are there any questions on number 1? Any questions on number 1? Do we remember this from yesterday? For the mean, add and divide by how many? Median, salt, and pepper till you get to the middle. Hopefully there's only one middle. Unfortunately, there were 2. Okay, add and divide by 2. And then for the range, just subtract highest and lowest. Any questions, number 1? Is that a hand, Kirsten? Okay. Number 2, what did you get? And we rounded to the nearest 10th if necessary, and it was necessary on number 2, Kirsten. What was the mean on number 2?
3.6.
30.6. What about the median on number 2, Griffin?
39.
That's the range. The median would be that middle number when you salt and peppered them away. Joel?
27.
27. Good. So it should have had a mean of 30.6, a median of 27, and then a range of 39. How many got all 3 of those correct on number 2? Does anyone need to see that worked out? Anyone need to see any of those worked? Let's go on to number 3. And what was the mean for number 3, Michael?
87.
Ooh, no. What did you get for your mean, Ben?
94.
Not 94. Should have been 91 when you add those all together. Those look like grades, by the way. But should have had a mean of 91. Let's go back to Michael for your median.
87.
No. Ben, what was your median?
99.
The middle number?
Oh, 94.
What do you have to do before you can salt and pepper and find your middle value? Gotta rank them. Did you rank them?
I don't know.
You don't know? Look at your paper. Did you put them in order? No. Okay, you have to. Okay, that's not just a Mr. Nadaski says this is a good idea. You must put them in order before you can salt and pepper and find your middle value. Do it exactly the way I'm teaching it. What did you get, Corey, for your median?
92.
Oh, the pain. Luciana?
90.5.
The agony.
91.
91 people. Come on now. Okay. The smallest number class is 83. Then there's an 88. Then there's a 90. Then a 91. Then a 92. Then a 94. Then a 99. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? That took me 5 seconds? 10 maybe? It doesn't take long. Do it. Now, salt, pepper, salt, pepper, salt, pepper. Hey, there's my median. It takes no brains. Don't blow the easy stuff. Like, if you blow the mean because you make an addition error, okay, I get it, you're human. Don't blow the easy stuff. Get the mean, or median, excuse me. Now, the range is also easy. It doesn't require much math. How do I find the range? Let's go back to Michael.
We subtract 83 from 99.
There we go. 99 minus 83 gives me a range of
16.
16. And then for the average, again, you add them all together, and I believe when you add them all together, you get 637, which you divide by 7, it comes out evenly to the 91 mean. Whew. Maybe I just called on the wrong people, but how many have, anyone have all 3 answers correct? I did call on the wrong people. All right, let's go to number 4. And now the wrong people to the right people. And what is the mean on number 4, Michael?
35.
Oh, Ben.
34.
Oh,
38.
38. Add them up. You should end up getting 280 when you add all 5 numbers together. You should get 280. Excuse me. 190. You should get 190 when you add them all together. Divide by 5 gives 38. What about the median, Michael?
35.
Oh, Ben.
34.
34. And then the range, Michael.
35. I just didn't like mark if it was the range, median, or mean.
Well, they were A, B, and C. Like, if you just write them in order, that would have been pretty easy there. The range should have been, Jalen?
29.
29. Number five. You add them all together. Let's see, there's 6 of them there. Yes, there are 6 of them there. And we should get 213, I think, when you add them all together. What do you get for your mean, Kirsten?
35.5.
35.5. What about the median, Elaine?
35.
35. What about the range, Corey?
11.
11 is correct. Number 6. What do you get for your mean when you add the 6 numbers together and divide by 6? Luciana?
56.6.
I'm sorry?
56.6.
No, Griffin?
66.
Well, round to the nearest 10th. It's actually 66.6 repeating, so we round to 66.7. If you said 66 and 2/3, I guess that gets you off the hook of rounding. What about for the median? What should we have here, Bryson?
65.5.
65.5, because you have 2 middle values. 66 and 65 are both in the middle. Average them out to a 65.5. And then the range should have been what, Joel? 16. Questions on 1 through 6. Okay. Don't make this hard. Number 7. Justin made the following grades on his last 6 quizzes. 76, 83, 91, 88, 80, and 86. By the way, are any of those grades obscenely higher than everything else, class? No. 91's highest, but it's not obscenely higher. I mean, he made an 88. That's only a few point difference. Any grade's obscenely lower? No, I mean, 76 is lowest, but I mean, he made an 80. That's only a 4-point difference. So we don't have any, what's that word for numbers that are either really high or really low compared to all the other ones? Ben?
Outliers.
Not outliers, outliers, because it lies outside. There we go, outliers. Class, say that word with me. Outliers. And there's no outliers here, which means that the mean is a good indicator of what's normal. Remember, if there are outliers, the best indicator of what's normal, class, is the median. Because remember, you just salt and pepper the outliers right off. No, outliers aren't a problem for the median. They cause a problem for the mean, though, because they skew the number either really big or really small. So the average is going to come out really nice here. What did you get for his average, his mean, for the last 6 quizzes? Michael, let's do this together, shall we?
Oh, I may have it. I have 84.
It is 84.
Oh.
Okay. There we go. All right. So, there we go. We add it all together, and we come up with 504, I think. Is that right?
Yeah.
Added, you got 504. And you got to divide the 504 by 6, and that's where we get 84 for the mean. Then for the median, Michael.
84.
Well, let's put them in order, Michael. My smallest number is,
76.
then,
80.
then,
83.
then,
86.
then.
88.
No, sir. Then
91.
91, okay? So these are the 6 numbers they gave me. I've listed them in numerical order. Obviously, we could salt and pepper the end 2 because it's a small group. We know that there's just going to be 2 middle numbers. How do I find what's in the middle?
Add and then divide by 2.
What do you get if you add?
169.
Yeah, 3 plus 6 is 9, and 8 plus 8 is 16. So 169, divide that by 2.
8. 4.
Put 1 left over, so 84.5 or 84.5, right? Should have been our median. What about the range that we should have had here, Michael?
20.
How do I find the range?
You subtract the smallest number from the largest.
So I should subtract what, Michael?
91 from 76.
Well, 76 from 91. 91 minus 76, and that should give us not 20, but
15.
15 should have been our answer there. How many had all 3 answers correct on number 7? All right, number 8. The 108th through 113th sessions for Congress resulted in the following numbers of public laws passed. They kept themselves busy. Well, they did for the first few years anyway, and then they got tired of being busy. Apparently, because they passed 498 laws the first year. Then 482 laws the next, 460, then all the way down to 383, then to 283, and then to 184. So Congress got lazier and lazier, or they just stopped being willing to work with each other, which is probably more likely. What's the average number of laws that got passed? Jalen?
381.6 repeating.
There we go, 381.6 repeating, about 300, it says round the nearest whole number there at the end, so about 382 laws on average during a year. What would be the median number of laws passed, Corey?
422.
Good, about 422. I believe it was 421.5, and then they said round the nearest whole number, so we'll say 422. And then what's the range of laws passed during that time sequence, Bryson?
314.
Yeah, we just subtract the 498 minus the 184 to get 314 laws on the range. Big gap in there. People need to do their job. Anyway, how many got those answers on number 8? Questions on mean, median, range. All right, let's quick review here with percents. Been a little while. We did some of this in the financial literacy supplement, though. Number 9, what's 40% of 90? 40% of 90. Griffin?
36.
36. 15 is what percent of 120? Kirsten?
12.5%.
12.5%. Excellent. We divide 15 by 120 or reduce it to 1/8. 0.125. 12.5%. And then 6 is 80% of what number, Elaine?
7.5.
7.5 is correct. Divide the 6 by the 0.8 and get your 7.5. Questions on the homework? Questions on that homework? All right. Flip back to page 283. Flip back to page 283. And we didn't get, in fairness, we didn't get a lot of chance to practice with the median. So while I say it's not hard, still it's not something we practiced a lot in class yesterday. Let's practice it a little bit more. Numbers 13 through 15 at the top of page 283. I want you to rank the data, find the median, find the range. Numbers 13 through 15 at the top of page 283. Rank it, find the median, find the range. So if you're finding the average, you literally add them all together and divide by how many there are. In our case, we salt and pepper, salt and pepper. These are the only 2 numbers left. So we add 11 plus 12. Careful on your addition.
33.
Well, 1 plus 2 is?
23.
There we go, 23. And then we're going to divide that just by the 2 middle numbers. Does that make sense? Because we're only going to average these 2. All the extra stuff, the outliers and whatnot, which there aren't any technically here, but all the extra stuff on the wings, it all cut off. It only comes down to these 2. Divide that by 2. There we go. Okay, now finding the mean. We're not averaging. Just rank them, find the median, find the range. It's just the easy stuff. We're cutting out the hard part. Because we've been averaging numbers, for years. We're good with that at this point, or should be. Good with the idea of it. It always comes down to execution and are we careful, but working here on median and range after we rank the data. Several people finishing. Take just a bit longer. All right, for sake of time, pencils down, even if you're not finished. Number 13, what was your median, Joel?
I wasn't able to do it.
Okay, Michael?
15. I mean, 11.5.
11.5, and then your range was
15.
15. Ben, on number 14, what was your median?
Number 14,
Uh,
36,
36, and then your range?
36.
The median's 36. How do we find range? Uh-oh, class, how do we find range? Big minus small. Biggest minus small. So how do we find range, Ben?
Biggest minus small.
There we go. So what two numbers do we have to subtract?
48, 29.
48 minus 29, class? 19 should have been our range there. Number 15, Joel, what was your median?
18.
18, and your range?
8.
8. There we go. Flip back, if you would, to page 281 for a moment. There's one more estimator of what's normal, and it's not maybe the greatest estimator, because let's be honest, if we think back to Corey's grades yesterday, there were a couple times where a grade was repeated. There was one grade that showed up 3 different times on the lineup. Did anyone remember what he got 3 different times? 100. He got 3 different hundreds. No other grade did he make more than twice. He had 2 90s, and a whole bunch of other grades he just made once. If we were to say, well, the grade he got the most often was 100, so that's normal for Corey. Corey's like, of course it is. Anyway, if we were to say what happens the most often, that would be what's called the mode. The mode, you see it there in bold, the mode is the value that occurs most often. This is not necessarily a good indicator of what's normal, particularly for numeric data that fluctuates. Okay, so mode is not a great indicator of what's normal, particularly for something that's numeric. But for things that are not numeric, this is a great way to do it. Look at that little list of eye colors there that you see there. Brown, blue, brown, brown, blue, blue, brown, 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 blue, brown, brown, other, brown, 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 brown. Okay, so anyway, obviously, which value, if you will, which eye color occurred the most often, class?
Brown.
Brown, which means that a normal eye color would be brown eyes, okay, based on that. Okay, and they made a little dot plot. That's what that little graph is called. You see how they wrote the 3 colors under the line, and they made a little dot every time that they got an eye color again. And so there were 4 times people had blue eyes, only 1 person had other, which I guess would be like a hazel or a green eye. And then there's a whole bunch of dots for brown. So it's very obvious brown eyes are the most common, based on that particular sample that was taken. Does that make sense? It may not be applied to the whole population of the world, but at least according to that sample, the brown eyes are the winners. Now here's the deal. There are times where you'll look at a set of data or a set of information, and there's really not one thing that really stands out. For instance, let's suppose Corey had, if we were looking at his grades, he had an 80, he had an 82, he had a 90, a 90, a 90, a 92, a 94, a 94, a 98, a 98, a 100, and a 100, and a 100. Well, yeah, I mean, technically, he had a few 90s, he had a few 100s. Like, those are the 2 things that showed up most often. But, like, he also had a couple 94s and a couple 98s. Like, there's really not one thing that stands out. Agreed? There are times that's the case, in which case you simply have no mode. You see that there at the bottom. If there's really not one thing that stands out, there's really no mode. Now, let's suppose that Corey's grades look something like this. Do you see that here there really are 2 standout values? Like these 2 things are way more than everything else. Here we'd say this is bimodal. It's actually 2 different modes, 100 and 90, but that's because they're so much bigger than all the other ones. They stand out. A mode has to stand out from the rest. So the mode is what occurs most often, assuming it kind of stands out. Obviously, brown stands out. Look at the next page, the blue box at the top of the page. It says find the mode for each group of data. Well, you see a line up there, and notice it helps if you rank the data, because it keeps all the like numbers together. 56, 58, 58, 64, 68, 71, 71, 71, 73. Do you see that 71 stood out from the rest, in that there were 3 of them? Nobody else had 3, so that's the mode of the data set. Make sense? Look at the next data set. 12, 13, 14, 15, 16, 17, 18, 19, 20. What occurred the most often? Nothing even occurred more than once. There is no mode. Okay? So there's not always a mode for a data set, but sometimes there is. And again, one of the strengths of the mode is you can use the mode for things that aren't numbers. For instance, look at page 283. We got a few little dot plots drawn there. choir members for a Christmas concert could wear either red, green, or white. Well, just look at the dot plot for a second, class. What was the most popular color among the choir members?
Red.
Red. So obviously the mode is red. We can tell by looking. Look at the vehicle list. Which type of vehicle was the most popular in the city parking garage? Trucks. Truck stood out above the rest. Truck is the mode. Look at number 20. Different sports associations that got highlighted each year. And notice, football didn't get highlighted very much. You know why? Because football's so awesome, you don't need to highlight it. Everybody loves it already. Now, as a guy who ran track, track gets no love. Like our track team, no lie, in high school, we were winning region championships and district championships, and the basketball team was winning nothing. Now, they got good a few years later, but they were winning nothing. The track team was winning it all. Cross-country team, we got no love. Basketball team got all the new equipment all the time. We were wearing jerseys from 10 years ago. I'm like, come on now, we're the only ones winning here. Why can't we get some new stuff? But anyway, it's all good. But obviously, which one of these got highlighted the most often, class? Track. So that's the mode. Look at the tourists who travel to different countries. Which country stands out above the rest?
None of them really.
None.
I mean, Italy and Japan are the two that stand out the most, but they're not that much higher even than China. I would say there's really no mode here. Now, if they both towered over the Brazil and China columns, then yeah, I'd say there's two modes. But they don't really tower over anything else, so the fact that there's two of them, I'd just say there's no mode on number 21. Does that make sense? We can do this with numbers as well. Look at number 22. Skim through the list. It would be best if we rank it, but we're running out of time. So for sake of time, is there a number that stands out on number 22, class?
17.
17 is the only one that occurs twice. It's the mode. Look at number 23. Is there a number that stands out?
41.
On number 23.
41.
41 there's two of, but also
17.
there's two 17s. Oh, do those really stand out? I mean, there's only two. So I'd say no mode on 23. Does that make sense? Look at number 24.
11.
No.
I see a couple of 11s.
Nine.
I see a couple of 9s.
5.
Oh, I see 1, 2, 3 5s.
Yeah.
Yeah, so what's the mode?
5.
5 stands out above the rest. Look at number 25. And by the way, do you see how it would be easier if they were ranked?
Yeah.
You can actually see it. So it's worth it. It really is if you have the time. It's worth it to rank the data. You can see it better, and you're kind of getting a glimpse of why it's so good to rank it. Number 25, you've been looking it over. Is there a number that stands out?
4.
I see 1, 2, 3 4s. I only see a pair of 5s. Yeah, 4 is the only thing I see 3 of. So 4 is the mode. Number 26.
29.
I do see 3 29s. I only see 2 14s and 2 17s. So I guess that 29 would be the mode. Look at number 27.
16. 17.
13.
I see 2 17s, 2 16s, 2 14s, 2 30s. No mode. There's nothing that stands out. All right, does that make sense what the mode would be? And do we all see how, if we'd had time to rank the data, man, that would have been helpful. All right, so in the homework tonight, when you're finding mode, rank the data first. Rank the data first. It'll help you tremendously. We're going to review over this stuff. The mean, the median, the mode, they all start with M. And range and rank, that will start with our confusing terms, right? So we'll review all of that on Monday. Homework for this evening is to do page 285. Page 285, the homework 12 to 22. Page 285 in the homework section, numbers 12 to 22. Have a wonderful rest of your day. Have a great weekend. You are dismissed.